Hey, hi everyone. Welcome to this tutorial on C, ICE, and lead classification using machine learning. Um, so AI or artificial intelligence has been booming recently, and you can see it all over the news. Machine learning is just a subsection of this where the intelligence develops on its own accord without, I guess, coding or explicit instruction to do so. Recently, there's been rapid development in this area, and now it's actually incredibly useful for many, many aspects. But today we'll be using it for Earth observation. Um, Here we can see the typical life cycle of a machine learning project, and we'll be working through a specific example to go through these 7 stages and exploring the core concepts. Um, We'll look at 3 key machine learning models, and by the end, we'll determine which one is the most effective, and we'll see the pros and cons of each. Okay, so this is my Google Drive homepage. I'm just showing you all of this for completeness. The location where we save these documents will become important later on. So firstly, I'm going to go into my Drive, this module. This is week 2. I've made a separate folder for this assessment so that everything's self-contained, and I'm not going to be affecting the rest of my work. Um, So the example that we're going to be looking at today is sea ice classification. So sea ice sheets are not in fact uniform. They have many cracks and fractures, which are called leads. And it's just due to the nature of how sea ice sheets are. They're constantly moving. And these fractures are actually significant because they allow for the transfer of heat from the ocean to the atmosphere. Um, which affects animal life, such as seals, polar bears, penguins, etc., and also human activities. So when people are traveling through the Arctic, they need to know where is safe to kind of go and where is not. And then also they can affect even like weather conditions and climate, etc. Go to like most traditional form of image or data, visual data analysis, and helps with our interpretations. Essentially, the way it works is there's like a convolutional layer, uh, which highlights a key feature that we'll be looking for. And there can be many features, and so there'll be many layers. And this essentially slides across the underlying image and identifies any matches to return a match, yes, or not, no. And this is the code for it here. The next model that we're looking at is random forests. The way this works is that there's many decision trees which all vote on a final classification based on the specific set of data that they're targeting. And this data is assigned completely at random, which is why this method works because there's no biases and it doesn't tend to like overfit or underfit the final data. Finally, the third model that we'll be implementing today is the Vision Transformer, or VIT. This is actually a relatively new development in this area, and instead of scanning pixel by pixel, it will generate patches or chunks of data, and it will analyze these as a whole. This is beneficial because it allows for the recognition of more broad patterns across like a larger area, and it helps this code work efficiently on a larger scale. Um, the only drawback, however, is it's very code intensive and it's very intensive on the computer's processing power. As you can see here, the code is much longer than the traditional CNNs. So now that we've briefly outlined each of the models, I'm going to just go through all of the code. So here we have the implementation of the CNN. And then we've plotted the loss accuracy graphs. Um, and you can see those here. And then also the confusion matrix for the CNN. Now for random forest, this is the implementation code. And again, we have the confusion matrix below. Um, Now for the vision transformer, this is the code. Like I said, it's much longer, and this took me a long time to run. Um, and like before, we have the loss accuracy curves here. Um, and then a confusion matrix at the end. So yes, that okay, so having examined each of these machine learning algorithms. The best model for our task of classifying sea ice versus leads has been the vision transformer. But each one obviously has its own strengths and like the benefits of each. So yeah, I think that's the end of this tutorial. Thank you for watching. Leave any questions in the comments below, and I hope you have a good day.